The distance formula. Nobody likes the distance formula, but we have to do it anyway. There it is. If you think it's very similar to Pythagorean theorem, you're absolutely right. The distance formula comes from the Pythagorean theorem, and the d in this case represents the hypotenuse of a missing triangle. So we're told that we have x sub 2's and x sub 1's and all the same thing with the y's. So what we do first is we label our points x sub 1, y sub 1, x sub 2, y sub 2. It doesn't matter which point you label the 1's and the 2's, as long as you do xy, xy, and as long as you keep the same number on each point. I couldn't do like, x sub 1, y sub 2, or y and x. It's got to be in that order. It just doesn't matter which one your 1's are and which ones your 2's are. Now I plug it into the distance formula. D equals a huge square root. X sub 2, in my case, is -4, so I'm going to plug in -4 minus x sub 1 is 3 squared, plus y sub 2 is 6 minus, and y sub 1 is -1 squared again. And now it's just a matter of doing PEMDAS inside of a square root. I have a giant square root of -4 minus 3, which is -7 squared, plus 6 double negative, which becomes a positive, 1 squared becomes 7 squared. -7 inside parentheses squared is 49. Regular 7 inside parentheses squared is also 49. And 49 plus 49 is 98. Now, I guess you could just throw that into your calculator, but what kind of fun is that? Let's make a factor tree and simplify. I already know that 49 and 49, so why don't I just make 2 and 49? And then I have 7 and 7. So the square root of 98 is the same thing as 2 times 7 times 7. The way you simplify a radical is you look for identical pairs. So I have a pair of 7's, bring that out. And my final answer, my distance, is going to end up being 7 times the square root of 2. Or a little under 10, 9 point something, 9.8 or 9.9 if you throw it into your calculator. But again, that's no fun.